24, very good. In 24, we have f of x equals natural log x. Perfect pick. So they want at a equals e. In other words, x equals e. We like to say a equals e because the general form is f of a plus f prime of a, x minus a. This is the general form. We worked on a few examples, but that's what it means. So in our example, this was 5, this was 5, this was 5. In this example, this is e, this is e, this is e. So first I have to plug in e to determine this. So f of e, so the linearization is f of e plus f prime of e, x minus e. Can anyone plug in e here and tell us what to replace f of e by? F of e is not
e.
Careful. F of e. If you have any doubts, use the calculator. See what the calculator is giving when you replace e in natural log, which is fine. What do we get when we replace x by e?
One.
Yes, thank you very much. Awesome. Can anyone give us f prime? F prime of natural log. I know everyone knows how to differentiate natural log. What does it equal to?
1 over x.
1 over x, brilliant. Now, can anyone tell us what is f prime of e? Because I have to put it here. And it's done. How much is f prime of e? Any?
1 over e.
Exactly, excellent. So this is 1 over e. It's done. Now I have to simplify it a little bit. So then L of x equals 1 plus 1 over e times x minus e. I have to distribute. So L of x is 1 plus 1 over e times x is, I didn't mean to write that, x over e minus 1 over e times e is negative 1. So the linearization is basically x divided by e. That's it. It's a line, 1 over e times x. Good. So that was part. I'll share my screen right now. So that was part. Find the linearization. We did. So this was part A. In part B, use the linearization to approximate the natural log of 2.72. So in part B, so f of 2.72 is approximately L of 2.72. How come? How do I know? Why? What's going on here? Yes, as long as this number is close to E. So I'm going to share my screen. And let's see if this number is close to E. So here's our E, best friend. Move away, okay, right? Second and division symbol. Very clear. And 2.72. I just wanted to see them side by side right here. So 2.72 is very close to 2.71. So that's why we can use the linearization. Okay, perfect. So 2.72 will be equal to, L of 2.72 will be 2.72 over E. And this I will approximate with a graphing calculator. And I will divide by E. Here it is. So this is approximately 1.00063,208. Now, when I plug in the function, because it's going to ask us 2.72, I have to get a number very close to this. Because using the linearization or using the function, they have to be very close as long as we are close to E. So natural log of 2.72, which is f of 2.72, is approximately 1.00063,188. So back to the book. Where's my book? So find the linearization. We did. Use the linearization to approximate. We did. Find natural log of 2.72. We did. What is the difference between the approximation and the actual value of 2.72? Minor. So this was part C, and here's part D. And part D, which one is bigger? The approximation is bigger than this, so I have to, so delta. Delta is the difference. So delta y if you want. Or I wouldn't call it delta y. Let me just say difference. Because delta y is something else, and I'm going to talk about it in a minute. Difference is 1.00063,208 minus 1.00063,188. That is the difference. So it's 208 minus 188. So 20 minus 18. So basically, I have 0.00000, let me see, 63, yes, 00, 3 zeros, 2 zeros, and 20 minus 18 is still 0.2. This is the difference. Very, very minor. Very minor. Any questions on how to find the linearization? Any questions on how to evaluate the linearization? Any questions on how to determine the difference? Any questions? Okay, so the last part of this section is a little bit more involving, but very simple. Oh, I meant to erase this, but still very simple if you pay attention and you follow me, please. Back to our best friend, f of x. Back to our point, back to our tangent. So I'm gonna put everything into a coordinate system. I'm gonna call this x. I'm gonna call this, of course, f of x. So this point is point P, coordinates x comma f of x. P, x comma f of x. Nothing new so far. I'm going to choose a point named Q, very, very, very close to P, but I'm zooming in, but it's very close. They're very close, but I have to zoom in. I have to show something here. I can't explain anything if the 2 points are so close. So they are very close, please remember that, but we are zooming in, and this is point Q, and the coordinates of point Q will be x plus a little bit. In the past, we called a little bit h for the difference quotient. This time we're going to call it delta x, this distance, very small, delta x, also denoted by dx. Can anyone give us now the y coordinate of Q? Can anyone tell us what is this? This is f of x. But what is this? And I'll write it here. Anyone, please try. When x is x, this is f of x. When x is x plus delta x or x plus dx, what do I get here?
A constant?
Say it again.
A constant?
When I have x, I get f of x. If I have a f of x, if I have x plus delta x, what do I get?
F of x plus delta x.
That's it. So I get f of x plus delta x or f of x plus dx. That's it. Thank you so much. Good. So here is, imagine the following scenario. Let's say we manufacture disks. Any disk, whatever it is. And there is an error in the radius. So I'm going to say this is the radius. This is the radius, but there is a minor error. It can be in plus or it can be in minus. It doesn't matter. So there is a minor error. So this is the minor error, or this. This is the error. A distance, a tiny distance. Instead of being, let's say, 10 inches, it's 10.01 inches. So then delta x or dx are 0.01. So it's not exact. It's a little bit more. Then obviously you see this difference will be the difference in the area of the disk. If the radius of the disk is not exactly 10 inches, but it's 10.01, this will be reflected in any function, in the area, in the volume of the disk, whatever. So this will be an error, delta y. So delta y is the error in y value, triggered by an error or a change. It doesn't have to be an error. It can also be called change in the y value, triggered by an error or change in x, called delta x. I'll explain the dx in a moment. So again, if there is an error in the x value, that error will create an error in the y value, because the disk, the radius of the disk should be here and the area here. Instead, there is a minor error that triggers an error in the area. But what is that change? It's this difference, right? This minus this gives us this change. This number minus this number gives us the exact change. And this is the exact. So delta y is the exact. Can anyone tell us what it equals to again? I just said it, but I want to write it. Did anyone pay attention what I said? What does delta y represent? How should I write it? So this is the delta y. How do I write it? What should the formula be for delta y?
F of x plus the delta minus f of x.
Exactly, excellent. F of x plus delta x, subtracting f of x. Indeed, that's it. And this is the exact. It's no approximation. I have the error, I have f of x plus the error, I have f of x, subtract the 2, and I get delta y. Awesome. Stay with me, please. One more concept here, and then we can work on problems. I don't want to put anything else in there because I already have a lot. So here's the point P, and here's point Q. we already identified that this was delta y. What I'm going to do next is I'm going to extend this line going through Q. And notice that now I have a right triangle here. This is the tangent line. This piece right here is, of course, delta x equals dx. And now I have another piece here, which is the one of the legs of this right triangle. So the base of the triangle is delta x or dx. This is the height, or if you want, the other leg. And this is the tangent. I'm interested in determining this piece. So in the right triangle, can anyone again give us what is the slope of the tangent line? So let's go back. This point has coordinates x, comma, f of x. How do I determine the slope of the tangent line at this point? So again, the point is x, comma, f of x. We talked about this idea at least twice tonight. How do I determine the slope of this line, of the tangent line to the point P, x, comma, f of x? What does it equal to? Anyone remembers what does the slope of this line? We had, you gave me 1, comma 5, and we determined the slope. Then we had the 5, comma 53, and we determined the slope. But how do I determine again the slope in general for x, comma, f of x? What will that be?